And now we're going to look at the reactions of alkenes. There's two that you need to know about. There's the addition reactions. The first one we're going to look at is the addition of bromine. So we'll start off with something simple like ethene. So you've got C double bond C and Br Br. This is much easier to happen than the substitution with an alkane. So the double bond is really, really reactive. So it breaks and the bond between the two bromines break, and you end up getting the bromine adding across the double bond. So one bromine on one side, the other bromine on the other side of the double bond. So if you look at this, see the double bond, see the bend in it, makes it really reactive, so it breaks open really easily. And then we have bromine like this, so it just breaks apart, and you can see we have an open bond waiting for a bromine there and an open bond waiting from a bromine here. So that's why we get that looking like that. The second one that we need to look at is the addition of HBr to an asymmetrical molecule or a not symmetrical alkene. So if you look at this one, we've got but1ene. So this carbon has two hydrogens on it. This carbon only has one hydrogen on it. Now Markovnikov's law, or Markovnikov's rule, I'll write it down soon for you, states that the hydrogen will be preferentially added to the carbon that already has the most carbons, or the most substituted carbon. So, and that happens most of the time, not all of the time, but most of the time. So if you look at this one, we've got HBr. This carbon has two hydrogens on it, so the hydrogen is more likely to be added to that carbon, and then the bromine will go to there. So your major product ends up being this here, where the hydrogen went to the first carbon and the bromine went to here second. Doesn't happen all the time. We also get a minor, where the hydrogen went to the carbon with the least amount of hydrogens already. So now it has two, where before it only had one, and the bromine goes to the other side, and that is the minor product. Okay, so the next addition reaction is between ethene and dilute sulfuric acid. Now dilute means lots of water. Okay, you dilute things with water, so that one you are going to add water across a double bond. So again, the double bond, one of the side of the double bond breaks, you end up with two open bonds. That means that we can break the bond between the water. So you end up with an OH adding to one side and the H adding to the other side. Now the same thing applies if you've got an asymmetric. So if this was butene or but1ene, so if it looked like this instead with a double bond, so if we had it like this with but1ene, then the water would be added across here, and the hydrogen would go to this side because this carbon has two hydrogens, and the OH would be added into the middle. Okay, so you end up with this. Okay, so it is 3 long, so we know that we are going to end up something that's prop. We know that this is going to break, and we know that we're going to get ClCl, and that is going to break. And because you've got two Cl's, it will just add straight across the double bond. So this is all the original stuff. That was what was there before, and here is the two Cl's that were added. Second one here, dilute, remember, means H2O. Know that we are going to break that. So if we put in all the stuff that we started with, can see that this looks exactly the same as that, except I've just got rid of one of the double bonds. That means that we can add an H to one side and an OH to the other. Now you notice, because both of these carbons only have one hydrogen each, it doesn't matter which side that you bond it to. Also notice that my bond goes to the O, not in between, and not to the H. Final one. So we have carbon chain that's 3 long. Put in what we started with. And we can add an H here and an I here. Okay, so the next, or the other reaction that you need to know about, is the oxidation of an alkene. Now you can only oxidize it with acidified potassium permanganate, so MnO4 minus H plus, and it will be oxidized to a diol. So if we look at this example of ethene, one half of the double bond will break, so we will get C, single bond C, H, 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 and we'll get a di for 2, so one OH on one side of where the double bond was, and the other OH goes on the other side. Again, notice that my bond goes to the O, not in between or not to the H. So if you want to have a go at this example here, hopefully you ended up with something that looked like this. Now I'll show you an example of it soon, but you've got purple, and this goes to a colourless solution.